Now before we move into our next section of Algebra 2, we need to go back and take a look at a concept that you should have learned in Algebra 1, but may have forgotten along the way, and that's the principles of roots and radicals. What things we're allowed to do and ways that we present information when we involve a radical symbol in the radicand. First, when we have the square root of x, we are looking for the item whose absolute value when multiplied by itself will give us the value inside. Now when you take a square root, for instance the square root of 4, there are actually two answers to this. There will be 2 times 2 equals 4, or a negative 2 times negative 2. So technically, for when we ask for the square root of 4, we want both positive and negative versions, but when we ask for just the square root in a typical situation, we're looking for what's called the principal square root, the positive version. When solving equations, we come up with both positive and negative because we have to count for all possibilities, but not in just everyday computations. Another part of working with square roots is when we have the square root of something that we can't directly take the value of. Square root of 24, so we're looking for a number when multiplied by itself will give us 24. Well, 4 times 4 is 16 and 5 times 5 is 25, so neither of those work directly. But if we were to take the square root of 24 and break it down, this is 4 times 6. And if you want to take it a little bit further, this is 2 times 2 times 2 times 3. Now when we're looking for square roots, there is a little 2 that sits out here. It's called the index. And what it says is we're looking for groups that size of items inside of the radicand. So we're looking for pairs of items here. And we have a pair of 2's. Well, a pair of 2's comes out as a single object. 2 square root of what's left behind is 2 times 3, which is 6. So the value of square root of 24 in exact methods is 2 square root 6. Another example, if we look at square root of 18, this is 9 times 2, which is 2 times 3 times 3, and again we're looking for pairs of items, so I have a pair of 3's, and our answer comes out to be 3 square root of 2. Same general principle applies when we're taking the square root of a fraction, is we can break it up into be the square root of the numerator divided by the square root of the denominator. Now square root of 6 we can't really do anything with, but square root of 9 is 3. So our answer here is square root of 6 over 3. As we move through, we are going to run across items that you can't take the square root of directly because it's a product of items or a quotient. Now when it comes to simplifying items that are a quotient inside of a square root, we do have some rules that apply, and one is called the rationalized denominator. It really means that when we are working with a fraction, we cannot have any square roots in the denominator of a fraction, and we can't have any things inside of the square root that have fractions themselves. So when we look at something like the square root of 5/11, we're going to have to simplify this, break it down as we did before into the square root of 5 divided by square root of 11. Now we are not allowed to leave that square root of 11 down there, so what we have to do is multiply this by the number 1 in such a way that we get rid of that denominator. Well, in order to get rid of a square root, we simply multiply an item by itself. So I'm going to multiply this by the square root of 11 over the square root of 11, because this is a form of the number 1. Now multiplying these, we're going to get the square root of 55, 5 times 11, divided by the square root of 121, which is 11 times 11. Now square root of 55 we can't do anything with, so we leave it as is. But the square root of 121 we can work with, and we get 11. So square root of 5/11 simplifies out into square root of 55 over 11. Let's apply the same principle to square root of 1/3. We get the square root of 1 divided by square root of 3. Well, square root of 1 we can work with. That is just 1 over square root of 3. But we cannot leave that fraction or that radical inside the denominator of our fraction. So I'm going to multiply this by the square root of 3 divided by square root of 3, which is the number 1. Again, you can always multiply something by the number 1 in order to not change it. Multiplying this through, we get the square root of 3 divided by square root of 9, which is simply square root of 3 over 3. So, again, this is a review of material you should have had back in Algebra 1, but might need a little bit of a reminder on.